Hello, welcome. Let's try to solve another Leetcode problem. So this is a very famous problem, 139 word break. So the problem is that we are given a dictionary. It is called word dictionary. So we're going to return true. So if this S can be segmented, so this is segmented means it can be split or it can be partitioned into a space-separated sequence of one or more dictionary words. So let's just check the first example to understand what does that mean. So if we have the lead code, we can split it from here. So this lead is inside of the word dictionary, and the code is also inside of the word dict. So we're gonna return a true. And let's just check the third case because it's gonna be a false. So let's just try to split it and check if that is possible. So maybe we're gonna split it from the cats, and now we have the add. If we have the add, what's left behind is only about OG. But what we have is the dog. We don't have OG. Yeah. So it means no matter what kind of split, we cannot find a true case. So for example, we can split it from the cat, and after that we have the sand. So after the sand we have the OG. It is not possible. Yeah. So this means no matter what kind of split, it is not possible. Yeah. So this kind of problem is called partition DP. And we just need to check if we can partition this string into different parts, and all those parts should be inside of the word dictionary. So if we want to check if a word is inside of the word dictionary, basically we need to turn this word dictionary into a set. So first of all, we're going to turn it into a set. Now, let me just record the length of the string, and we're going to start the DFS. So normally you can also use a dynamic programming directly. So in my other videos, I prepared a dynamic programming directly, but in this video, I prefer to do it with memorization. So we're going to use a cast, and we're going to start the DFS with memorization to solve the problem. So we're going to start from index 0. So finally, we're going to call DFS with 0. So the condition is that we're going to start from the beginning. So the index I going to start in from 0. So if I equals to the length of the string, so we're going to return true. So this means it is a possible partition. So now, so this is the base case. Now what do we need to do? We need to find all the possible partitions. So for example, from A, is A inside of the word dict, or is AP inside of the word dict, or is APP, or APPL, or APPLE if it is inside. So we're going to start the next DFS. So it's going to be starting from this pen after that. And if this pen is still inside, we're going to start after this apple. And apple is still inside, so we're going to return a true because apple is still inside. Yeah. Now, let's just split it. So for j in range n, so we're going to check if the word is inside or not. So it's going to be starting from I to j plus 1. So for example, if j equal to 0, at least from the beginning, we need to take one character. So we're going to prepare j plus 1. So if this is j equal to n minus 1, so this j plus 1 going to be equal to n. So this is going to be the whole string. Yeah, so this is why I used j plus 1. Or you can use other kind of a method. You're going to use n plus 1, starting from 1. It is still okay, but I prefer this kind of writing because it seems it is much simpler than that. So if this is inside the word dict, what are we going to do? We're going to record it. So we're going to go for the next DFS. Yeah, so it's going to be starting from j plus 1. But this is just one of the cases. We need to check all the cases. If there's one possible case, we're going to return a true. Otherwise, we're going to return false. So basically, while you are running the DFS with memorization for the partition DP, from the beginning, you're going to set the result to be a false. Now, from here, we just need to check if there's a one possible case that's going to be true. So we're going to use it OR. So the result is going to be equal to result OR DFS j plus 1. Or you can use the bit manipulation. It's going to be the same idea. Yeah. So finally, we're going to return the result. So we just need to check from the beginning, the result is going to be false. So if there's one possible case of splitting, so we're going to return true. Otherwise, we're going to still return this false. And the else condition is if I equal to n, it's going to be true. Otherwise, it's going to be the false. Yeah. So let me just run it to have a check. As you can see, it works. And now let me just submit it. As you can see, it passed all testing cases, and it's pretty fast. And the time complexity, I would like to say this type complexity is going to be On square, because this is a DFS I with memorization, so this I going to be starting from 0 to n minus 1, and for here we have another loop, so it's going to be On square. Even though we checked if there's a word inside of the dictionary, but normally I think this is going to be O1 time. So if you don't believe it's going to be O1 time, or you can say it as O20. So the final time complexity is going to be 300 square times 20. Yeah. But I prefer to use it as O1, not instead of 20 for this kind of calculation, because if I were to check if a string is inside a set, so I'm gonna say it just as O1 time. I believe by using the hash table, they have some kind of encoding to encode the string. It is not like we're gonna check the string one by one and check if it is inside. Maybe they have some encoding, but yeah, sometimes they say it's gonna be O20 for this one. Sometimes they say it as O1, but I think it is okay for us. Maybe we're gonna use this 20. So 20 times 300 square. So basically, it's gonna be 18 times 10 to the power of 5. So it's going to be 1.8 times 10 to the power of 6. So this is going to be the final time complexity. Thank you for watching. See you next time.